Not very good. It shouldn't be 50-50. Oh. We do the test. We are looking at the difference in the chi-squared. And the idea is that the difference in the chi-squared is not passing the critical value over here. So the baseline fit is this much. That doesn't tell us, whether it's good or not at the moment. I mean, you could go and see the other goodness of fit measures, but the baseline fit is all about whether these items actually load on absorption. Yeah, so that's not very interesting. But now we are imposing restriction on the model. So the logic of the test is, if I pose the restrictions, I pray to God that the fit of the model does not get worse. So it's a little bit like, how bad can I make the model in terms of the restrictions without making the chi-square shoot up into the sky? That's the game over here. So after I pose this restriction, and it's a pretty solid restriction, because now you're saying that the questions not only load on the same factor, but they have to have the same value. They have to be the same in terms of quantity. They have to predict the absorption to the same degree. So that's a pretty tough restriction to pose. And you can see that the tau equivalency test has not been passed. So tau equivalence is when the coefficients are the same. And you see that the chi-square difference is 74.24. Now that's a difference, and the difference in the degrees of freedom in between these two scenarios is 5. So what you're looking for in the tables, in order to say whether this number is large enough, whether the fit has worsened to a substantial degree, significantly worse fit. So that's all. The question is this number large enough? And you find out whether the number is large enough by looking at the critical value for this chi-squared. So you go to the tables and you look at the chi-square for 5 degrees of freedom, and you find out it's 11, approximately. And that's at the significant level of 0.05. So that's the acceptable significance level. So I'm giving you this number because you need it in order to say whether the test is passed or not. And because the value is 74 and the critical value is 11, well, that number is much larger. That means that the fit has worsened substantially. It's significantly worse. So this means that the tau equivalence test has not been passed. The coefficients cannot be set to be same to each other. They're very different. Okay, then I increase the restriction one more step. I mean, at this point, it's pretty pointless because you know that the next restriction is not going to pass. But the idea is that now you restrict the errors as well. You can see in the table over here that they're the same. So the errors and the coefficients have to be the same. And you do the same thing. You look at the chi-squared, which is telling you about the misfit of the model, and you see that the misfit is huge now. The difference is, again, 5 degrees of freedom in between these two models, because you're estimating less information over here, so you have more degrees of freedom. You are at 19, so the difference is 5. And you see that the difference in chi-squared is 140. And you know that 140 is much larger than 11. So the critical value has been surpassed. You are off the chart. Your chi-squared is super large. It's much larger than the critical value. That means that the test has not been passed. So the hypothesis 0 in all of these, in both of these tests, is that the original or the baseline fit is the same as the tau equivalent fit. And then the next hypothesis 0 is that the tau equivalent fit is equal to the parallel fit. So there's no change in chi-squared, and you've rejected that hypothesis. So you rejected the idea that the fit stays the same. It doesn't. And you see that the chi-squared is increasing, and that's not a good thing. That means that there is a larger misfit, so that's a negative thing, and this model is by far the worst. So meaning the harshest restrictions also create the worst fit. And that means that by no means can you say that the errors and the coefficients are the same for all the questions. So these items over here are not interchangeable. Because if they would have the same impact on the factor, you could just change them, you could delete one and still have a very nice scale, right? They would be interchangeable. They would have exactly the same impact, the same loading on factor. And they would also be the same in terms of accuracy because the error term is the same. Okay, so the correct answer was no.